great to be here. I was just thinking back to a year ago when we had our last meeting launching this, our efforts in the Rocker projects under the CZI support with my colleague Noam Ross, who is here but is also managing another meeting at the same time. And Noam was fielding questions about this virus in China because he works at EcoHealth Alliance, which focuses on these issues. And yeah, what a year it's been. So things have not all gone, exactly according to plan, as we've been juggling kids at home and the virus, and in California, all of the fires. But I still wanted to take this opportunity to kind of tell you what we've been up to, and also really get your feedback, because this community is super important to us. We learned so much at the last meeting, and really being able to kind of go into nuts and bolts and get ideas is a special opportunity and really constructive. So please reach out. I already got some great comments just moments ago from the chat on one of the issues we're looking at. So with that said, let me jump back, give some staging. So the Rocker project basically provides Docker images for the R environment. We started in 2012. Our images have been downloaded, or I think about over 8 million downloads all told. And they're used by academic infrastructure projects, by several commercial companies, and by lots of individual users. And we're really a community-driven project, so we move forward largely by community contributions. And that has been great fun, but has also created challenges that this support from CZI has helped us to address. We identified kind of 3 big challenges. One was making our code base more modular, so it's easier for people to kind of rebuild in their own directions. So our images have typically provided a very linear stack of images. So you can see a kind of list of images, and they just kind of add new software on top of existing software, making a more and more complicated stack. By making our code refactored, it makes it easier for people to grab what they need and rebuild it in their own way. And I'll show you in a moment kind of our approach to doing that in kind of nuts and bolts. One of our other big goals, and one of the motivations for doing that kind of refactor, was the need to support GPU-based computation, particularly for machine learning applications, but also for other applications that require a rather different approach to support the GPU drivers. And so we've taken a big whack at that as well. Our third topic was to improve our documentation to help people navigate both of those changes. And so we needed to kind of figure out what those changes were before we really revised all of our documentation. So that is still a work in progress, and we haven't quite wrapped that up. So we've actually extended our current load of current CZI funding to give us a little bit more runway to do that. You can find our preliminary documentation up here at the rockerproject.org. Okay, I want to take a quick look at what we mean by refactoring our code base here. So we used to just provide Docker files. So that meant every single thing had to be in the Docker file. And as you can see, you can quickly get lots of them. So there's also a lot of redundancy in this. So a file for the 4.03 stack looks a lot like the file for a different version. So under the refactor, instead of writing all these damn things by hand, in this Rocker version 2, which is our refactor, we have made an automated build process to do that. Now, there are a variety of different ways to go about that, but there were none that fitted perfectly into our workflow. And there's nothing that's really kind of, at least as far as we can tell, emerged as the standard way to automatically go about generating your Docker files. So after trying a couple alternatives, we settled on this alternative mode called a stack, where we specify in JSON the kind of nuts and bolts of what has to go into a Docker file. This allows us to put kind of all of the environmental variables that control versions and details in one place, where a user can quickly tweak them to build an image that has different support. And it meanwhile allows us to put all of the details of the installation process in standalone scripts. Another piece of our transition in refactoring was to move from our original Debian stable-based images to Ubuntu-based images. This kind of shifted our alignment to match up more with what other community projects were doing, so we could benefit from many of their work as well. One of the big pieces was that at the same time, the RStudio project has launched its own package manager, which is finally building pre-built binaries for Linux. they've taken a slightly different approach to the many wheels approach on the Python side. This requires that we align our images quite closely with the Ubuntu long-term stable releases. It was great timing that Focal Ubuntu 20.4 came out right as we were diving into this, so we were tied to a relatively recent release, and we continue to update these as new releases come out. That's great because you're pulling in the relatively latest compilers and so forth in the process. So this means images build much, much faster. We now have binary builds for all of our packages that can bring build times from an hour for an image down to a couple minutes. It also is great for users downstream who are customizing our images and adding loads of their own packages. That was just one of the benefits of kind of shifting over to the LTS stacks. The other has been that it has allowed us to coordinate our development on those scripts with other packages. So these are just standard bash scripts, and they're not really specific to our project. So this install RStudio will run more or less in any Ubuntu Focal environment. In most cases, we can support multiple LTS releases, and that allows that script to be shared across projects as well. It has also made things more modular because all of these install scripts are available across all of the images. So what does that mean? If you start off with our stack here, say you just grab the vanilla RStudio image, but later on you decide you need the geospatial libraries. Well, hiding inside the RStudio image is the install script for geospatial. So either in your derivative Docker file or just in your live container image, you can just run the Docker scripts, install our geospatial.sh bash script, and it will add that standard set of libraries. All of these images are designed the way that we have always built Docker, with a strong eye towards version stability. So all versions get locked. We've been able to do that with Package Manager as well, because RStudio provides snapshots of those packages. This is great because previously we have relied on what's called MRAN, Microsoft's snapshots of the CRAN-R packages system. And we've heard from the grapevine from Microsoft, it looks like they're no longer as interested in supporting that as they previously had. So it's been great to have another community member step in and provide those snapshots that let us kind of rebuild our image at any time, grabbing exactly the versions of the packages that it was built with at first. So that's the kind of reorganization in a nutshell that has allowed our build system to become a bit more diverse. It's also allowed us to spin off more flavors. For example, in the geospatial community, we've added different tags to support some of the bleeding edge development packages, versions of things like the core geospatial libraries like Geos, Proj, and GDAL, which particularly with the Proj package system after it being decade probably at version 4, finally quickly moving up through version 5, 6, and now 7, that has caused the whole geospatial stack to update really quickly and has been a real challenge for developers in that space. So having images that can provide any of those different versions and provide them stably has been a big help for the R community. So we're really glad that we've been able to kind of jump into that space more quickly with our modular images. Lastly, the modular images have helped us step into the GPU computing world. And so we have a separate stack here kind of nested within this. So you can get the base image Arver in vanilla version, but also with the NVIDIA CUDA libraries support built in. And that currently we're supporting 10.1 and 11.1 drivers. And then we have specific CUDA only stacks that go on top of that, ML for machine learning, and then MLverse that kind of add a whole new suite of packages on top of that. And because it has those sort of nested components, you can add other components. You say you need the geospatial libraries on top of the Arver CUDA thing, you can just sort of swap those in relatively easily. So far we're pretty happy with this modular development. It has made things a little bit more complex if you're not familiar with it. And so that's where we really need to kind of up our game in the documentation side and just getting more user and contributor experience. And so that's kind of all down the road while we're balancing, all that 2020 has thrown at us. I want to stop there and just see if there are any questions or things we can discuss before I kind of drive in more. I'm also realizing I can't keep an eye on the chat at the same time. So let's see what we got here.
You have your first question from Sarah on chat. Read it.
Yeah, great. No, so I just read it. That's a great question. So one of the things that we'd love to include, right? How do you go about extending containers yourself. Hopefully, most of this now will work pretty quickly out of the box, that if you need, for instance, another R package or another Python package, there's almost no need to write a new container. You can just install in the usual way. So our containers for version stability, when they are at latest, they keep pulling from latest. What we do is when we move them, we have always tied to R releases. So when a new R release comes out and you're no longer on the latest R release, so now you have the explicit 4.0.2 tag, this will guarantee everything else, all the other versions also get locked to whatever version they were at when that became no longer the latest version. And so again, it should be relatively easy for people to build on those images and either get locked versions or get the latest versions. Now, sometimes you're building something where like the compile times are really long or whatever, and you want a pre-built image. So I can go into how you would extend that, but basically you can more or less follow our recipe, and it's pretty simple. We are now just looking into adding PyM support for the ML stack to help us deal with different Python versions. It's not uncommon to need, even in a single container. In these cases, we've seen people will have 2 different R packages and they depend on 2 different versions of TensorFlow. And of course, TensorFlow's 1.x series doesn't support the current 3.8 Python that you find on Ubuntu 20.04. So PyM should make it relatively easy for our users just to say, grab a virtual environment for Python for this project that's tied at 3.6.9 or 3.7.9 instead of Python 3.8, and you can have different environments in the same settings. Great, I have a bunch more questions.
I'm sorry to cut you off, sorry. Different R versions as well?
Yeah, so all of the images are tagged by R version. So any of the images you see here, there is always a tag for the R version. We didn't display that all that well here. You can see, for instance, in the stacks, each stack is built, this is the R version. So if you put the R version basically at the end of the image, you get that R version. If you don't put the R version, you get the latest version.
This is awesome. I'll look into switching everything over.
Great, licensing is an important thing. Yep, exactly. So we've worked closely with RStudio since day one. You do technically require permission to package RStudio, the RStudio project inside a container, and you're not supposed to just go ahead and add that to any container. So we have been, as far as I know, the only project that has been officially approved since 2012 to bundle the RStudio with our Docker images. And you should really get in touch with their licensing. I think we have some comments now still at the bottom here. Nope, haven't moved those over yet. They're still on our version 1. You should still get in touch directly with RStudio if you're distributing RStudio. Last I heard, everyone is supposed to explicitly get permission. I think there is some recognition that there's a challenge there, but if you're deriving from the Rocker image, then you're inheriting that permission directly from them. Yeah, thanks. Yeah, the community has been super supportive with the switch to Ubuntu, starting with the R 4.0 and forward. And we know that's also been a bit rocky for some folks, and we've learned a lot by doing that as well. As similar as Ubuntu and Debian can be, those differences matter a lot too. We hope that Rocker is useful for non-Docker users. We actually have many users that don't know that they're using Rocker. For instance, at my institution, they now provide students, which has been great for online learning, with just an environment that's really based around Jupyter Hub, but it's using Rocker images under the hood to go spawn on a Kubernetes cluster and RStudio instance. And so the students just go to a URL, and there is RStudio server sitting waiting for them. They don't know that they're using Rocker under the hood. The people that are teaching classes in my department don't have any idea that I have developed the images that or co-developed some of those images that they're using in their class without having anything to do with Docker. That said, if you can kind of use it to deploy your own images on a server, you can learn only just a little bit of Docker, basically install Docker and copy paste Docker run. This gets you a base R image. This gets you a functional RStudio image, and you should be up and running.
Since we have time, let me just read my comments. It's not a question. I just want to mention that I've been using Rocker in a lot of my projects. and especially the modularity has been really, really useful that you've been working on recently. So kudos for that. Again, it's not a question. Just want to say it's a great project.
Thank you very much. It's really great to hear. When you change things, as you all know, you always hear where it breaks. It's hard to know sometimes who it's working for. It's also been amazing how much scientific infrastructure we've learned, like, for instance, needs old versions of Fortran that are no longer supported and so forth. And you think that using the latest LTS release would be a good standard, but yeah, supporting old versions is remarkably important, and so we're glad we can do that. But it does make things a bit bumpy, and I'm sure other projects are familiar with those challenges as well.
I was wondering when the switch to Ubuntu was made, I was wondering whether I could suggest to also support, because sometimes in the scripts you check which version of Ubuntu is being used to install some package or another, and I was wondering, like, why couldn't you also add Debian in there? But in the end, I just kind of swapped all of my packages to use Ubuntu as well, and it was worth the hassle, because now everything just works seamlessly.
Yep, exactly. I mean, and the scripts are still a bit of a work of art. So, for instance, we have tried in some cases to be as flexible here as possible in checking things like the Ubuntu version. Can we still support 1604, which is about to be out of life? On the Python side, there's a variety of things like this for Python, and I don't know which one is dominant in that community. But I could try to follow up with, we have the group that does the MyBinder project. So checking with those. Yeah, S6 is a really good question too. S6 is a init manager, which lets you run multiple services in a container with a really nice, and it works really nicely. It's really lightweight and works nicely with Docker. It's added in the RStudio level images, but you can now add it in any of your images because there is, of course, an install S6 init script here. And at the same time, we have thought about, but haven't yet managed to move away to provide RStudio-based images that just run RStudio and don't have this kind of multiple serving multiple things at once model. We think that could also be useful. So right now, yes, the RStudio instances are all tied to S6. You can add S6 in other images if you want to run multiple things, Shiny plus RStudio plus a bash or a SSH daemon plus whatever else. Yeah, the Jupyter stacks are pretty cool. We try to work with them as well. They've been a super big input for one of the image stacks that provides a binder, which provides a Jupyter hub on it. There have been, just a flag, people may have already seen this, RStudio broke some of that integration when they changed the RStudio releases since 1.3, and we've been trying to kind of work out some of those details still. So there's still kind of a little bit of friction, or there's a new source of friction, I suppose, in being able to launch an RStudio instance from an image that is also providing a Jupyter hub. But we're resolved two of the big issues there. Hopefully the last one will be resolved by the RStudio team sometime down the line. Yep, the R and Python thing is fascinating. I've learned a lot about that just by my own group. Now we're jumping into the machine learning and calling a lot of Python from R, or just working in Python from RStudio, and it's pretty entertaining. It's amazing what you can do there, but also there are some interesting challenges on both sides with navigating versioning and so forth.
Next up, we've got Sarah talking about Common Workflow Language.
I'm going to assume not everyone is familiar with Common Workflow Language, so I'm going to start out with a brief explanation of Common Workflow Language and then go into some of the details. But before that, let me introduce myself. I'm Sarah Wade-Zaronic, and with me today is Peter and Michael. If we could unmute them when we're doing Q&A, that would be awesome. Or if they have the permission to unmute themselves, that would also be great. I don't know the best way to do it, but they're with me today. And I'll get going again. If you look in the corner there, there's a tiny URL to the slides, but we'll also put them up on the repo that CZI is starting. But if you want to follow along, there's a tiny URL. I also put it in the chat. Okay. So just a little background, and probably all of you know this, but computational workflows are super important in biomedical science. And they're also super important in terms of, well, when we're doing, we're trying to do science in general, we want to be able to reproduce our results, right? And so how do we combine computational workflows and be able to do replication and validation and kind of extension? Well, we get into some problems because some workflow systems aren't fully supported for the lifetime of those computational workflows, or the lifetime we want to use them or share them or extend them. Also, they might not be, you might not be able to run them on the hardware that you have. So let's say that you want to share a workflow with a colleague or reproduce something you saw on the paper and you get the workflow, but it doesn't run on the infrastructure you have, or it doesn't work with the workflow language that you've been running. And so this really hampers our ability to extend and have scientific progress. So this kind of idea is why CWO was created, that there was this idea that we needed a multilingual workflow description standard that worked between systems and that allowed for cross-vendor portability. So this is how CWL came to be. So what is CWL generally? Well, as I mentioned, it's an open standard for describing analysis and workflows. It's designed for data-intensive sciences. And in this case, we're talking about bioinformatics, but it's also used in other data-intensive sciences. And it's defined with a schema. It has a specification and a test suite and a reference implementation. In this case, it's called CWL tool. But there's also other implementations. There's academic implementations and commercial production implementations, and I'm going to show you running a couple of those today. And it's portable and scalable across software and deployment environments. So you can run it on your laptop, you can run it on a cluster, you can run it on a grid. And to do this, it uses containers, so Docker, Singularity, and so forth. So CWL isn't just the standard, it's a project. And so sometimes that gets confusing. What's the standard? What's the project? So the project you can think of kind of as the overlying thing. So what's the project? So I thought it would be useful to put a slide with the mission of the project. And the mission of the project is basically to support all the process around creating the standards. And so kind of the pre-standard process, the standardization process, and the post-standards lifecycle, and kind of everything that involves that. And so what does that mean? Well, the pre-standard process really is having a place to convene to discuss and propose and test ideas about the standard. And then it's actually the standardization process. So actually writing it down on paper or typing it up or whatever. And then doing that in a very consensus-based way, community-based way, and we follow the open stand principles. There's a link there if you're not familiar with them. And then it's post-standards, so that whole life cycle. So promoting the standards, maintaining any tools and training for the standards, and then tracking the standards if we have any deficits, if we have any feedback, and then cycling that back into the next release of the standards. So it's that whole cycle itself. So hopefully that makes sense. It's not just that middle part of writing down the standards. The project actually supports that whole life cycle. So we've kind of been talking about CWL on a high level. So I want to get into a little bit of the details about what the standard actually is and what CWL actually is. So it's a file that contains a workflow description, and there's a viewing of what a CWL tool or workflow description. This is actually a workflow description here on the right-hand side. It was generated with something called CWL Viewer. And this is what I'm going to use in the example today. It's a workflow that creates a pangenome. And I'll talk about it in a little more detail later, but that's kind of a description of what the workflow would look like. It's a view of it, showing the inputs and the outputs and the steps. And it's human readable. It can be written in JSON or YAML or a combination of the two. And it has optional fields that allow you to increase the reusability and the readability. And these also allow you to do things like create really nice GUIs on top of it that allow people to customize inputs and allow people to build utilities that allow people to kind of remove themselves from having to create all the input files themselves. And so some tools do that. The inputs and outputs are explicitly stated. It's designed to be modular. So the workflow graphs are actually designed. Each step of them can be described as CWL tool descriptions. So you can build your tools and then build a workflow out of the tools. And as I mentioned before, it's designed to be run on a variety of platforms. So it's designed to be supported for a high throughput computing. You can distribute the steps of your workflows on compute nodes, and the movement is handled by the CWL runner for that. And we encourage vendor extensions. So that means that there's different implementations of the standard by different vendors. And so vendors can make their own extensions as long as they follow the standard. And so then vendors can progress the standard their own way without hurting portability, as long as they have their own part, as long as it follows the standard. And so some vendors do that have things that are unique to their implementation, so that they can progress the standard in their own way without hurting the portability. Okay, some more technical details. Going a bit more, diving a bit deeper. Workflow graphs can be exported as linked data. So CWL supports provenance and the ability to export that provenance information using existing provenance standards. If you're interested in what data, how to do that, or what standards it supports, there's a link there. And the object model of the standard allows you or your infrastructure of your implementation to allow to do optimizations if your implementation, sorry, hard word to say, supports that. So you can do cost or data location aware scheduling. So if you want to schedule a step where your data is, or a step where maybe a particular node or a particular instance is cheapest, you could do that. You can cache results. So if you've run a step before and the inputs haven't changed and you want to reuse that step, you could do that. If your implementation allows you to do that, you can stream in and out between steps if your implementation allows you to do that. Again, we allow people to do that in their implementation if they choose to. We also have hundreds of conformance tests that allow us to ensure portability and independence of vendor. So again, if you have conformance tests, so that then if you have a CWL workflow, you know it will run on all the different implementations if they pass these conformance tests. And then we also have workflow validation, so that you can catch a lot of the syntax errors before you even run them. Okay. So let's dive now into an example. So what I wanted to do is show you running a CWL workflow that's the same workflow on 3 different implementations of the standard. So the workflow we chose, we wanted to show a real workflow. So something that was doing something that was in reality, that was a real workflow, that wasn't just a toy example. And so what we did is we decided to make a smaller version of a workflow that was from this project here, which is this PubSeq project, which was designed as part of the COVID-19 biohackathon in April. And it's this project, what it was designed to do was you can upload a COVID sequence, and with metadata, it does some checking on the metadata, checking on the sequence, and then it builds a pangenome, and then it makes both the sequence and the pangenome, updated pangenome, available for download. And it triggers all of this automatically as soon as you upload your data. So underneath all of this is a CWL workflow. So we took that CWL workflow and we made it a little smaller just so it can run in just a couple of minutes so we don't sit here. And we're going to run it on 100 FOSTA files. Again, I'm used to using human data, so I'm like 100, that's going to take forever. But I'm like, oh, they're COVID sequences. They're not human sequences. If you deal with human sequences, that would be funny. Or if you deal with viruses, that would be funny because they're so different. Anyway, I don't hear laughter, but I'm going to assume it's just because you're all muted. So what we did is we took this CWL sequence, and then we, the same exact sequence with the same exact information, then what we're going to do is we put it on a GitHub repo, and this is the actual GitHub repo for the, this is the actual GitHub repo for the COVID-19 hackathon, but we have a one for the demo itself. There we go. And we took a version of that, a simplified version of that, and the same code we're going to run on 3 different implementations of the standard. One is a reference implementation, so that comes with the standard essentially. It's called CWL tool. Then we're going to run it on Toil, which is an academic project out of UCSC, which is another implementation of the standard. It's designed to run on HPC clusters, on grid computing, and so forth. And then we're going to run it on Arvados. Caveat, I actually work for the team that works on Arvados as well. So just caveat that I do that. Arvados is an open source implementation, implementation as well. It's a commercial open source, just so you think like Red Hat and whatever, we self-support. So what we did is we have the workflow here, and it's simplified, but it's a real workflow. So it takes in the sequences and it outputs a graph, and it has multiple steps, a graph and a visualization of the graphs. It cleans up the FOSTA, it does some alignment, and it builds the graph and it visualizes it. So there's multiple steps. And this is a little bit about what CWL looks like for you if you've never seen it before. And each of these steps has a CWL itself to describe what's happening there. So if you look, tools are each of the steps, and I could show one to you very simply here. This is one of the steps. It's running this command. This is doing the alignment. And it has a Docker file to associate with it. This is one of the steps. So now I'm just going to run it on the same exact code, 3 different implementations, just to show you how cool it is to have a standard, right? And there's particular things you could add or subtract for the vendor, and it may run it slightly differently. It could distribute it, it could reuse things, and so forth, but it will work. Okay, so now is when you have to say, okay, Sarah, does it actually work? So now is me doing the live demo, okay? So everyone hold their breath, right? Okay, so I'm gonna open up a couple of windows. This is all in the same machine. So first, let's just run the reference implementation, okay? So here's just the CWL here, you can see, and the YAML file to define the inputs, which is just gonna be the FOSTA sequences. So I'm gonna run them in this little directory called runs. And I'm gonna first do the CWL tool, which is the reference implementation. Everyone following okay? Makes sense? Everyone can see this. I upped it up to 14 fonts, so I'm hoping it looks okay for everyone.
Looks great.
Okay, I have the CWL command here. So it's just the command to run the CWL, which is again, the CWL tool, which is the reference implementation. And then again, it's just CWL tool, the CWL, which defines the workflow, and the YAML, which defines the input. So just so I don't have to, you guys don't have to watch me type, I'm just going to do a little cut and paste here. Okay, now this is going to be running the CWL tool, which is the reference implementation. It takes a couple minutes to run, so it's going to start there. While that starts, we're going to close this one down, just make it smaller, and we're going to start another one. All right, so this is another one. Okay, so let's start another one. Let's move this so it's kind of overlapping. I think this one's a little smaller, so we don't have to deal with it while we're looking at this one. Okay, so that's running the reference implementation. So while that's running the reference implementation, let's send one to an Arvados cluster, okay? So this will run in parallel on an Arvados cluster on a couple of nodes. Okay, so let's look at what the Arvados command looks like. Yeah, it will look very similar. So just so you guys know, I'm not cheating with you. Again, it looks very similar. The no wait just means, hey, give me my prompt back when I'm done, okay? So I'm just gonna cut and paste again, run this, and then we can see it running on Arvados. And I'm gonna set all these up to run because they took a couple minutes to run, and then we'll go back and check and prove to you that they've worked. Everyone okay with this while I'm doing it live? While we're
You're doing great. I'm giving you a 3-minute warning.
Okay. Okay, so this is going to run on Arvados. So this is submitting to Arvados. It's going to tell me it's sending to Arvados. Okay, and then if we go to Arvados here, let me open up a little link to the Arvados cluster here. Whoop. Oh, no. You got to see the homepage for the Arvados cluster. Here it is. It's queued. It's getting ready to run. Okay. Good. Submitted. Ready to run. Great. And now let's do Toil. So Toil, if I can get the right one open, I'm going to run on a Docker container. You heard about Docker containers already a little bit. See if I can open the right one. Nope, not that one. Always the wrong window. Okay, this is my Docker container for Toil. I'm running Toil in a Docker container because I didn't want it to, it's installed it, interfered with my Arvados install. Same place, right? Everything looks the same. And just let's look what the Toil command is. Oh, I have to actually go in there correctly. Yeah, same thing. A little more information about, oh, that's my, and then all this outputs for all of these are going to be, are already on the GitHub. So you can see them, but then again, I'm going to cut and paste this and we can run it. Okay, and now it's running on Toil. So now these are all running for us. I'm running out of time a little bit, so let's just go back to the slides and then we can go revisit this. So what are we doing with the CZI funds? We are working on our community ecosystem by creating a mission statement. We didn't have one, and organizing a mini conference. We are maintaining our specifications. We just did a new release of our specifications, and we're updating tools such as the CW viewer. You saw that snippet image of a CWO workflow and code documentation tools. And we're working on both our formal and informal documentation. We're doing introduction to workflows with CWL training tutorial, which is software carpentry style. And Toby, who was, I think, in the group, is helping us with that. And a website revamp to help our users as well. And this is just how, if you are interested in participating in the CWO community to get started, the best place is to just go on the website, and all these links are there. But there's a getting started guide. We have a bunch of places to interact with the community. We have a forum, we have Gitter, just the GitHub, and also we're active on social media. We have a weekly video chat. And also, if you're interested in getting funding to help work on CWL, there's a nice European funding opportunity, and you can talk to Michael about that in any of the breakout rooms if you're interested in that. So I'd like to close out. These are some of the benefits of having a common workflow language and why it was created. It's a vendor neutral open standard. It's a community first project. We really designed it with an open and transparent governance, and you're interested in how the governance work, it's all described on the website. It improves interoperability and portability. It increases reusability and reproducibility. It enables parallelization and scale. And it's supported by an ecosystem of tools, libraries, and an editor plugin. So that's where I want to end. I'm happy to answer any questions, and we can go back and look at those outputs, but I'll ensure you that they're going to be running, and I can show you the outputs if we want to do that in some of our Q&A time. Or you can just go to the GitHub repo and see the outputs there. And Peter's taking some nice screenshots, or a link, there's a link actually to the Arvados run, so you can see some images there as well. Thank you.
Awesome. Thanks a lot for the opportunity to present. It's kind of a shame we can't all be together, but we're really kind of been happy to be part of the CZI community. We started Nextflow quite a long time ago now, back in 2013, and it really started as an academic project, something that we were doing in the lab ourselves, trying to solve a problem, doing multiple sequence alignment. And it really kind of has grown on, and it kind of taken on a life of itself. Maybe to provide a little bit of background, I think I had a very good introduction there Sarah before in terms from CWL. There's many common aspects to both of the projects there, and I think it really sets us up very nicely. But I'll still provide a little bit of background onto Nextflow and then go on to some demos as well. So what we're trying to do with Nextflow itself is focusing on these data-intensive pipelines. So really the kind of computation which is complex, which you need to distribute across multiple computers or servers or the cloud nowadays. So this is the kind of computation which you would say is very different from, say, the first talks where we saw the likes of using RStudio or Jupyter, which is very much more interactive computing. We're focused on the other end of the spectrum there. And in doing so, there's some challenges which exist for a lot of scientists and engineers these days. So being able to deploy these kind of analyses anywhere securely, this means on their own infrastructure or on their own private cloud or on their own cluster or on the laptop if they need to. We really want to enable best practices in terms of software engineering. So this is bringing the likes of containers to scientists, making sure that people are using things like GitHub in terms of the end-to-end Git-based version control. Also, the way we want to provide a way for users from all backgrounds to be able to use the kind of workflows that we have. So this means lab technicians who maybe need to kick off some jobs from a GUI all the way through to systems engineers who need to make these workflows part of much larger frameworks. So the workflows themselves, this is an example of one looking at from NF Core. This is an example of a pipeline looking at germline versus somatic, so kind of variant calling and cancer. And this is very much an idealized view of what these things look like. So you have a series of steps, the data has to go through, and you have a series of software which kind of goes through that. In reality, there's a much more complicated. This is an example of a genome annotation pipeline. And you can see that each one of those circles is a software, is a tool or a script that has to be brought together, and then managing and deploying these kind of applications or these data analysis pipelines becomes extremely complicated. So Nextflow is there to kind of solve this problem, essentially. And what you do with Nextflow is it's both a programming language as well as a runtime. And this means that you can write code in any language. So developers can write R, Python, command line, and you kind of wrap what we call these processes or these individual tasks inside these process blocks, which are then linked together using data flow programming. Data flow programming is a very powerful way that you can essentially drive the execution of a pipeline. Those individual tasks, then we define the dependencies for them using containers, for example, Conda, and then the whole script itself becomes a Git project, which is able to then be executed from the various platforms that we support. So Nextflow has integrations with all of the major cloud providers, with actually Microsoft coming very soon, and as well as support for the grid schedulers. So these are the likes of Slurm and LSF, et cetera, as well as Kubernetes, and of course, a lot of people still do a lot of local execution itself. What does it look like? Let me provide an example of people who haven't seen Nextflow before. So imagine that you had a script like a command like this. You're running from the command line. You had a sample. You wanted to align it against a reference. In Nextflow, you take the original script that you have, or original command line, and you wrap it in these process blocks. This is a simple example where we define the inputs of that task. We define the outputs, and then we have a section where we're going to essentially call the command. Notice that we don't have to change anything, and what we do here, we can use any scripting language here. I then want to link these things together, and this is where the kind of magic of the data flow comes in. You can see that the output, in this case, the BAM channel, becomes the input of the next process. And this kind of implicit linking of the processes together provides the data flow aspect to it. In terms of how it works, so Nextflow is a DSL. This is a domain-specific language. It enables you to have very fast prototyping. So we've written a syntax on top of another programming language. And that other programming language is called Groovy. And this is you can think of it as kind of Python for Java. It allows us to, in situations where we're not able to, with the language, where the Nextflow itself is not able to perfectly solve your problem, you have access to an underlying programming language for the kind of corner cases. Nextflow uses this data flow programming model. as I said before. And as well as that, we had an idea very early on that each task should be self-contained, so it lives in its own working directory. And this very much led to the idea and enabled the idea that we could have tasks as containerized tasks. Essentially, each task is independent of itself and then can be run on different infrastructure, so that you can even have hybrid workflows, which each of the individual tasks to run across these different infra. Finally, a key part is the separation of the logic of the workflow, so kind of how you define your tasks and your processes from the execution logic, so from where you execute. And keeping these things very distinct is really important to providing the portability that we see with the Nextflow workflows. Nextflow itself, we've had some sort of big advances over the last year or so, and probably the biggest one that we've had is this DSL2. Sorry, I think there's a lot of background noise. Apologies. With DSL2, which is a way of modularizing the Nextflow code itself. So what it enabled us to do was separate out the individual linking of these processes together. I'll provide an example here to show you. Here's an example of salmon, and what we're doing here is defining a quantification task. And inside that, we can define exactly like we did before, but now we're no longer implicitly linking the processes together. So there's no channels in this case. The channels themselves come from the workflow section here. So I can see that I'm invoking the process very much like I'd invoke a function. And in doing so, it enables us to split out the various aspects of the pipeline logic and really provide this modularization that comes about. Jumping away a bit from the syntax of Nextflow, Nextflow is very powerful for running on multiple infrastructure. So a very common way of doing this is onto our HPC system, where Nextflow submits the individual tasks to that system. In this case, this is an example of showing something very similar like to Slurm or to LSF. So Nextflow is submitting the individual tasks to that orchestrator, then using a shared file system to take the input data, run that task, and using the shared file system for the output. What's become very popular, though, is this idea of managed cloud orchestration. This is an example here using AWS Batch, but there are similar services, Google Life Sciences, and Azure Batch. And as part of this, Nextflow submits the job to the API. And as far as the user is concerned, they just simply say that they want to use Batch. The virtual machine will spin up, the tasks will be able to run, and then the output data will go back to an S3 bucket where it's able to be used. In practice, what that looks like is we have very much a concept of configuration, which is separate from the workflow script itself. So I run locally, Nextflow run, going to be running on my local machine. I can add a config into my config file. I want to run with Slurm. You can notice here that we have this concept of an abstraction for the queue, for the memory, CPUs, etc. And then I can provide that same change. If I wanted to now run that same pipeline on AWS Batch, I would simply change the executor to Batch. Still have the same concept of a queue and memory and CPUs and container, and the pipeline would then be able to run on AWS Batch. Nextflow itself, the community has grown quite a lot in the last 2 years, I would say. It's probably where we've seen the most kind of growth, and a lot of that has been around just the kind of developer community which is developed around it. Something that's we've been really excited to see is not just the community contribution to the open source project, but actually the contribution of pipelines themselves. You can kind of think of these as the content creation of the project. There's really people sharing their pipelines and sharing their kind of knowledge of how to use Nextflow itself. Then adoption has also really been an enterprise situation. So people who are running in cloud, very large organizations, who are probably cloud first to a certain extent, also very large amounts of data and kind of running more production-like settings is where we think Nextflow seems to be most widely adopted in that sense. So that's a little bit on Nextflow. And now kind of jump into more of a demo session. As part of that demo, I'm going to be showing Nextflow Tower, which is a project we actually just released around a year ago now. Nextflow Tower, there's an open source version of this. We also have this running as a free service on tower.nf if you want to check it out. So what we can do with Nextflow Tower is essentially a way of managing your Nextflow pipelines. Tower is simply running Nextflow in the background, and it allows people to have a user interface to interact with and kind of show highlight a little bit about what Nextflow pipelines are able to do and how you can use them. The deployment itself, you can deploy Nextflow Tower the same way as Nextflow, so on any of the infrastructure. So we support AWS as well as any kind of Kubernetes-based execution, or even locally on your laptop. So I'll just jump through and show you this, show you tower.nf and provide some examples of how we can run these pipelines. You can log in here using any kind of authentication. So I'm just going to use GitHub here. When I launch into Nextflow Tower, they have a concept very similar to Nextflow itself, so having different compute environments. I could, for example, take any Nextflow pipeline, which is a Git repository. Here I'm just going to show an example of a genome consensus generation pipeline from COVID. So I'm able to, for example, just take a Git repository ID, can go into Tower, and when I launch here, I can choose any of the compute environments. And notice how I'm not actually changing anything in the pipeline. I'm only going to actually put in the pipeline itself. So in this case, I've got set up for batch, dual, and Slurm. Once I select this, I can paste in the Git repository ID, and then I can use a revision. This is going to be looking up a commit ID, a tag, a version that you have in GitHub using the API. And then I can, for example, in this case, it's going to be using S3, choose a profile. Again, this is reading the Nextflow API, and then launch the pipeline. So this is the same process that you would do for any cloud, for your on-prem, for local, etc. When you do this, though, what's happening in the background is that Nextflow is going to be submitting to the API, in this case, into Batch API. The jobs themselves will go into a queue, very much similar to how you'd have like in your own on-premise queue. And then from there, those jobs will then spin up machines. In this case, I'm using EC2 instances, which will run those jobs. And all of this is sort of happening in a very transparent manner. So this is happening on the user's account, on anyone who wants to sign up, provide their credentials, and then launch in this way. Other things that we can do in here and that we're kind of building in for this in the future is the ability to have actions, for example, the initiation of a pipeline based on an event. This could be a git commit, for example. Also the kind of standard credential management that you require from dealing with this kind of infrastructure itself. We have full kind of readability, so you can go through a pipeline itself, see the individual tasks that are launched. In this case, it's a very basic pipeline, but I could go through and see the resources, could go into an individual task, and then from that individual task, I could even go and see the execution logs. This is quite a challenging thing of debugging these pipelines when you're running in the cloud in particular, because all of the logs and all of the actual data where it's there is typically in a bucket, or it's typically in some on the virtual machine, which has come down and invariably died at the point of failure. And in doing so, we'll be able to capture the logs, present them in a way that enables researchers to really jump in and understand what's going on and debug it, as well as some metrics around CPU usage, memory, etc., which is all captured by Nextflow. Okay, you can see that this one here is now running. I can get an execution log of that, and I could launch the same pipeline into any of the infrastructure. Okay, I'll just jump back into the slides there. Where we're going with this, we also have sharing and collaboration. We see this as a big part. Researchers who want to necessarily work on a pipeline, maybe they need some help from a colleague, from a researcher who's on the other side of the world, who maybe needs to come and see exactly what's going on, and then run that same pipeline, that same execution on their own infrastructure that might not have access to the same on-prem or to the same cloud, and they want to be able to do so in that way. We've also released this whole thing as an API. So Nextflow Tower itself is from a public API, which you can find on the website there. And this kind of enables all of the extendability of Nextflow itself. As part of that, we're also releasing a pipelines feature. This will enable users who are maybe not so experienced in using the command line, or maybe not even so experienced in understanding the technicalities of the particular pipeline they launch. Imagine that they're not the one who wrote the pipeline. For these kind of users, we want to provide a much nicer interface for them to be able to interact with these pipelines, but also to have sensible defaults, to have descriptions of what the various fields mean. And we've been working with NF Core as part of this to develop this standardized JSON schema, which is going to be to define the inputs of a pipeline so that this can be rendered into a form for use. There's also some extended documentation which you can find over at tower.nf. As part of this project, so we actually wrote this way back in February, I believe. So we're actually only just getting started with the project now. So we are part of the second phase of this, and this project is a joint one between both Nextflow and NF Core. As part of that, we kind of set some joint goals between the two projects. So some of ours were really up to reaching this 8,000 monthly users of Nextflow. I think we've just surpassed that in the last couple of months. I know that the NF Core people, we're over 1,000 people on the Slack now, so that's been some tremendous growth in the project. So maybe we need to update those over the next year or so. Other things that we wanted to be able to do as part of the funding was to support more public clouds. So this will be to be able to build in more support for the Kubernetes, for Microsoft, for support for people who want to run on different infrastructure. I said there before to add in these notebooks, so to be able to mix in this interactive computing with batch-like computation. GA4GH has been a big one for us. So Nextflow now has support as the Global Alliance for Genomics and Health, support for the task execution schema, as well as the workflow execution schema, which we have support through now via Tower. NF Core has been doing a lot of work towards the adoption of the DSL2 standard, which has come about, and there's been some really nice work on that the last couple of months. The other things there, we've been a little bit limited in terms of what we've been able to do in terms of in-person conferences. So we had— 1 minute. Awesome. We had plans to be able to do more of that work around kind of getting out in terms of in-person stuff. We've managed to do some online conferences as part of that, and some NF Core hackathons. But there will be more of this to come over the next year, hopefully. Finally, this is, as I said, is a joint project. I'm now going to pass it over to Phil, who will be speaking after me and talking about NF Core.
Thank you, Evan, for the great talk and for segueing so perfectly into my talk. And thanks for the invite and the opportunity to speak today. It's really nice to be part of this community, and it's really nice to see people from other projects as well. Kind of seeing people talk about Plotly that was used in some of the graphs that Evan was showing in the Nextflow reporting. I think Salmon is here. We've been just talking about Salmon on the NF Core Slack just now, and chatting to some Rob Patra and others about how best we should be using it in NF Core and stuff. So it's kind of nice seeing all these diverse parts of the community all in one place. So I will. So this works beautifully actually, because Evan's given a great introduction to Nextflow itself. And so then I can kind of talk a bit about how NF Core is different and how we kind of take the underlying Nextflow infrastructure and try and build that into a community. Because that's really kind of the heart of NF Core, is we are a community effort built around the original Nextflow community, but focused on making a curated set of analysis pipelines built purely using Nextflow. So obviously we have a set of pipelines. That's what most people come to us for, is to use the pipelines that we've built. I originally called the project NF Core back when we started because we were kind of focused on core genomics facilities, but the project has grown a lot since then. And now we have pipelines for genomics, but also proteomics, image analysis, and all kinds of other things. So we're sort of slowly growing, and also, of course, plenty of research groups and others use the pipelines. We have guidelines, which were actually the first thing we started with, because Nextflow itself is a language and it's super flexible and powerful. And of course, that means you can build anything with Nextflow, and you can write your pipeline in 100 different ways, and you can choose to use some of the support it has for best practices or not. And so with NF Core, we say, okay, everyone who works with an NF Core pipeline, these are the standards you need to meet, and these are the guidelines. Some of them are about code quality, and some of them are a bit more kind of philosophical. For example, one of the more unusual ones is we say that we only have one pipeline within NF Core per data type and analysis type. So we have a pipeline called RNA-seq, And that is the only pipeline we have for doing RNA, regular RNA quantification. There's different ways you can use that pipeline. So there's different options for tools, but we have just one pipeline. And the same for methylation-seq or attack-seq or chip-seq and so on. We also say that all of the NF core pipelines have to be built the same way using our template. And this means that they all run in the same way. So once you've kind of set up your configs and everything, and you've get one NF core one NF core pipeline to work, you can be pretty confident that they should all work on the same setup. And of course, if you're running a core facility or something, or if you're just running different types of data, this is great because you kind of just invest that work once, and then your deployment and your running of all these other pipelines is really smooth. And then finally, we've started building our own tool sets, kind of external to Nextflow, but are kind of companion tools, both for people running pipelines and also for people developing pipelines, to kind of automate things as much as we can and also improve the user friendliness. And as we've started to do that, we've thought a lot about standards and trying to kind of standardize things. So as of today, the pipelines, we have about 40-something pipelines, so 27 which have a release on GitHub, meaning that they've gone through the full kind of community peer review system. We have at least 2 more which are just waiting for their final review, so we're nearly at 30 now. 14 pipelines under development, so they haven't had a release yet, but some of these are already being used in production at various sites around the world, and 4 archived because we never delete a workflow for reproducibility. And what, of course, I'm most excited about is the community. And this is really what's grown way beyond my expectations of when we started this. We primarily work everything on GitHub, everything with an MIT license and fully transparent open source. We use Slack for all of our kind of conversation, direct messaging. This is actually something that we've helped to fund using the EOSS grant, so it's really great to kind of see that work. And then we do outreach with Twitter and YouTube, and you can find all of this information on our website. As Evan mentioned, last week we hit 1,000 Slack users, which, as you can see by our rather modest goals of reaching 150 Slack users, this has sort of taken us by surprise, but it's fantastic to see. And you can see that we've got hundreds of users spread across the different platforms. So obviously many more people using our pipelines than we have developing, but lots of people contributing in all kinds of different ways. You can visit this webpage, and all of this is graphed in real time with daily updates, so you can kind of really dig into various aspects. Okay, so if you're new to this, what do you need to do to run an NF core pipeline? You have to have Nextflow installed, and then you really need to have either Docker or Singularity or Conda installed, or some other container engines which are gaining support as well, to handle all the software requirements within the pipeline. And then optionally, you can have this Python tool that we've written called NF Core Tools, which is the helper kind of software. So typically, you would kind of go off and check out the NF Core website and maybe browse through the pipelines and kind of find one that you like. And then you can kind of hop onto the command line, which is typically where most of us kind of actually use Nextflow. And if I use NF Core, then there's a bunch of commands in here which can help me as a user. Kind of a first bunch here. So I can list the pipelines like I just saw on the website. I can list all the different NF Core pipelines, and I can kind of search them as well. So look for a keyword RNA just to pull out any pipelines which mention anything to do with RNA. And then these are all kind of hyperlinks that go to the website. And we can see also using this tool whether I've used Nextflow to grab these pipelines onto my system and whether the local copy I have is up to date with the most recent release from GitHub. So that's just kind of convenience. And then one of the other things which Evan touched upon is that we've been developing a kind of a new standard which we've called this kind of Nextflow schema, which is based on the JSON schema standard. And this is because when you build a pipeline, we use all these parameters to kind of customize how it runs and tweak with different options. And the bigger pipelines especially can start to have a lot of parameters. And it's easy to make a typo, and sometimes it's a lot to read. So by using a schema to describe all the different parameters within the pipeline, we can start to do things like setting different types, validation of those, and so on. And I can use this now to do NF Core launch, which is like a slightly more user-friendly way to launch a pipeline. In theory, any Nextflow pipeline, I think, should work. So if I do nfcore launch attackseek, it will find the local copy of the attackseek pipeline that I have. And then I can choose to use either a web-based or a command line interface. So if I hit web-based, it will take me off to the nfcore website. But again, this could be using the schema from a local pipeline that I've written myself, and builds a web form, which is a lot more easier to read. We can kind of navigate through it. It's got all the help text built in next to the different things. And if I click launch, it will try to validate my inputs and say, okay, something's wrong here. When I hit launch, it gives me if I'm using vanilla Nextflow, I can just run the Nextflow command with this file, or I can run this command. But actually, the command line's been running in the background the whole time, and it will have seen that I've submitted this form. And so I can just choose to run that right here. If you're running offline or something, maybe you don't want to use a website, or maybe you don't want to put these things through a public website, in which case you can do everything locally with the command line version, which uses the excellent library called Rich in Python to render Markdown even, so we can see kind of a help text and everything written on the command line. Again, validation is inbuilt here, so it works in very much the same way. The same file then, of course, can be used for all kinds of other things. So if I go to the nfcore website, I can find my pipeline, and you'll see that we have documentation, which is automatically built from this file. And we can also launch directly from a website as well, which does the same thing, but just takes the pipeline schema from here. And finally, what I think is quite nice is we added this little button. So if you are using Tower, which we're very excited about, which Evan showed, then you can hit this button and it will take you straight off to Tower with all these parameters that you've just filled in on the nfcore website. So the two are really kind of talking together. Okay, so that's all if you're using a pipeline, if you're a user, but we also have command line tools to help people if you're building a pipeline. So the main one really that everyone starts with is called nfcore create. And this takes the template that we've built and that we're constantly updating to kind of form the boilerplate for the best practices of what we think a Nextflow pipeline should look like. We put in a few things, a few variables here, and it will create a kind of a simplistic pipeline for me, but one which will run no problem. And what you'll see in here is there's a lot more than just a Nextflow workflow and config and everything, but we have kind of all kinds of other things like we have GitHub actions set up and all kinds of other stuff here. Once you then go on to develop this pipeline, you can do constantly run the command which is called nfcore lint, which does code quality checks on the pipeline. And as far as we can, checks that you are adhering to all those different guidelines, which I told you about. So I can run this on my brand new pipeline and it will check everything. I've just been working on this code, so hopefully I haven't broken it. And it will run through a lot of different results and tell me that most things have passed, and I've got a few warnings, but nothing failed. There's some quite nice stuff here. For example, if I'm using Conda, then it will check whether there's new versions available. All of these link to documentation about the given test here. And you can see here that it's telling me about to-do strings. What that is in the pipeline, we have special comment lines built into the files like this, which are flagged by the linting, where basically it just tells you, okay, in this file, you need to do something here, you need to add something here. And so you can kind of, that leads you through building your pipeline from scratch, and those lint tests kind of flag things. Okay. Those lint tests I mentioned also run on GitHub as CI tests. So every time you push a commit or every time you open a pull request, those same lint tests run and check that basically you haven't broken anything. This kind of level of automation we find is critical when we're quite a large community with hundreds of different developers, some of whom are very new to Nextflow and GitHub, contributing to a fairly limited number of different pipelines. So we have lots of people coming in, and we want to make sure that people don't make mistakes or kind of, and these automated tests are really user-friendly in way of checking that the code quality is still good. One of the things we've just added, which I really like, is this, where those results are actually automatically posted to the pull request as a comment now. And this is great because if you don't have any failures, then the CI test will pass and you'll get a little green tick, but you probably won't notice all those warning messages, which might be quite useful. But now if you have any warnings or failures, then you'll get this comment posted there telling you exactly how well it's gone, and again, with details with links out to the documentation. So I've kind of already described this a bit, the Nextflow schema, but I'll tell you a little bit more about how it works here. So it's based on the JSON schema format, as I described, and basically this file, once built, allows us to automate a lot of stuff around the pipelines. Input validation, command line help, documentation, and end user interfaces, and whatever else anyone else can think of. The longer this is around, we're finding that other projects are starting to use these files, which is exactly what we hoped for, and that's kind of why we started with a standard. Building some kind of huge JSON file is not any fun, as I'm sure any of you will sympathize with me on this, and especially if there's lots of pipeline parameters, these files can get huge. So actually, the very first thing we did was we built a more kind of user-friendly or developer-friendly tool to build the pipelines, the schema for you. So if I hop here into my demo pipeline, and I'm just going to open up my code editor here, and I'm going to go into the pipeline config file here, and these are all the different parameters which I can use as command line flags to change how the pipeline runs. And I'll just add a couple more here. And then if I go back and do NF core schema build, this command line tool will check the pipeline config and check the schema that I already have and see if there's anything missing. And sure enough, here it's found these extra parameters that I have built, added into the pipeline. Now, to customize the schema that it's built, it's going to give me the option of running a web browser tool again to build the schema. And this is a UI specifically for developers. If I collapse all these groups, you can see that my new parameters have been added to the bottom here. And for things like documentation and stuff, it's really nice that I can start to like add some logos or some icons to it. I can write descriptions. And I can even write my long form text here. I can't type apparently. And I can kind of preview how it's going to look on the command line and also in the website. I can choose the different type of variable types so that it's validated. If it should be a number, it should be a number, and so on. Put in default values, say whether it's required or not, and have type-specific options. So, for example, if it's a string, I can say it must be one of these options, and then the UI will build like a select drop-down box, or it must match a regex, or if it's a number, it must be between this and this, or it must be an integer or whatever. So I can really kind of add in those validation systems, and then I can also group the options. So if I make a demo group here, I can add these new options in, and I can drag and drop the order that they work, and I can also drag and drop the group itself. And so I can start to really organize all of these different options into more manageable chunks, along with embedded documentation and everything. And while I've been doing all this, it's been building this massive JSON schema file underneath for me. I click finished, and again, the command line recognizes that I'm done and writes that to my file for me. And there's my new diff, which has been created by the web tool. So this is really, really easy to use as a developer. You don't need to know anything about JSON. You don't need to know anything about JSON schema. You just need to do your work on the pipeline and then run that command and kind of use a graphical interface. And as a result, we're really seeing great adoption of this new standard for the NF core pipelines and hopefully beyond. Right, Evan mentioned that there's a big iteration of Nextflow, which is called DSL2, which is like a whole new kind of syntax almost for how Nextflow pipelines can be written with modularity. And so NF Core, we were really excited about this. It gives massive flexibility and power to the pipelines that we can build. And the obvious thing for us was to build then a library of kind of tool wrappers. Several other workflow language communities have equivalents to this, and it's a really nice way to kind of share implementations and again, kind of have a common set of code that people can use. And so we're building currently a repository called NF Core Modules, where we're putting in these different tool wrappers. And this modular design gives loads of different advantages. The pipeline code gets much shorter, much more readable, easier to maintain and understand. If we're using a common tool like FastQC or something which is run in lots of workflows, there's just a single place to maintain that, and all the different pipelines can stay up to date with that and stay in sync. And also we use the same software images, so it's kind of better for space saving and stuff. Now that we're breaking these workflows right down, we can put in proper automated unit testing at every single step. So that FastQC in this repo, we can say, okay, run tests where we check the inputs and outputs and make sure that every time we modify this wrapper, that we're really sure that it's working properly. So we'll hopefully give much more reproducible results and kind of better code quality. And of course, if you have this library ready to go and all the tools you want to build your pipeline with, even if it's not an NF core pipeline, are in this library, then you can kind of run really quickly with the helper tools. So we have like an NF core modules install command, and it will copy all the right files from this repository into your pipeline and then keep them up to sync if you want to. So really fast to build new pipelines. Okay, to wrap up, you got a sneak preview just then. I'm very pleased to say that we were managed to be published this year. So if you're interested in finding more, you can check out the paper. It's nice and short with lots of details on the supplementaries if you're curious. And of course, go to our website, the NF Core with a .NET, where we've got all the documentation, and we're kind of building on the documentation in a really big way at the moment. Or of course, drop us a line or chat on the CZI Slack. Bioimaging workflows. Sure, sorry, I shouldn't have stopped sharing my desktop there. So we have this pipeline, which is our first kind of image-related pipeline, which is image mass cytometry. So, basically, now I want to share my screen or the chat disappears. Basically, Nextflow pipelines can have any tools you want in. It's just a series kind of commands. So if you have command line tools that you can run for your image analysis, then you can build a Nextflow pipeline. And if you're interested in building a pipeline and making use of all these cool tools and the community, then please come and join us, and we'll be happy to help out. One of the things I really like about NF Core is we have a real kind of mixture of people in the community. You have people like me who are really excited by automation and tooling, and Nextflow, of course. And then around each pipeline, you have like kind of a little sub-community of people who are really interested in the biology of that pipeline. And the experts, quite often we have people who write the underlying tools also writing the NF Core pipeline. So you have kind of domain-specific experts there. So come join the Slack if you can, bring your friends, and we'll help you out with building something.